Hi there, this is Prof. Johan from the Department of Chemical Engineering at the University of Pretoria. Welcome to my series on the Introduction to Chemical Engineering and Chemical Engineering Principles.
In this video, I want to talk about concentration. And I'll see if you go read Wikipedia that concentration is typically denoted as the quantity of something in a certain volume. This per volume is typically for solutions, but in chemistry, there is more to concentration than just per volume. We can see concentration as something mixed into some mixture. All right, so let's look at some common concentrations used. The first one I'm going to talk about is if we have mass per unit volume. Now, I'm going to denote this in SI units. So I'm going to say this is the kilogram of the thingy I want, the material I want to know its concentration of in the total mixture. Kilogram thingy. And this is now going to be in cubic meters of stuff. So mass per unit volume is denoted as the mass of the thingy, the component, over the cubic meters of everything together. I can also see this as the kilogram component over volume of the mixture. So the next one is going to be mole per unit volume. So we can express this as the mole of thingy over the cubic meters of stuff. Other variations we can have of this mole per unit volume is molarity, which is expressed as per liter solution, which means it is gram mole thingy over liter solution. So the next one we have is molality, which is per 1000 grams solvent. So this is gram mole thingy per 1000 gram solvent, which is equal to gram mole thingy per kilogram solvent. Now you can see from these first four concentrations that all of them are some sort of mass. Now whether we're talking grams, kilograms, kilomoles, gram moles, over some sort of volume, cubic meters, liters, or 1000 grams, 1 kilogram of solvent. So these concentrations are the classic concentrations we refer to, where we have some sort of quantity, a mass, in some sort of volume. Now, the volume can be the total volume, or it can also be the volume of the solution, or it can also be the mass of the solvent, or the volume of the solvent. Please take note of this and take care regarding these. Okay, so the next two I'm going to talk about we have discussed before, and they are mass fraction, and from this we also can have mass percentage. This is going to be kilogram thingy per kilogram stuff, or equals to kilogram component over kilogram total. So I'm going to express this as the mass of the component over the sum of the mass of all the components. And as I said, we can also express it as a percentage, where we have the mass fraction as given above, multiplied by 100 to become the mass percentage. Next, we have the molar version of this, where we have mole fraction, and again, the percentage version of this, where we now have this as the mole thingy over the mole of the stuff, or express it exactly the same as above as the mole component over the total mole, which we can write as this equation, and then the same again for the mole percentage, where we multiply the above quantity with 100. The next one I want to talk about is ppm and ppb, or parts per million and parts per billion. ppm and ppbs are variations of the quantities above, the mass fraction and the mole fraction, except for that the base that we're using now is a million or a billion. So for ppm, it implies it is a thingy over a million, and for ppb the same, but now over a billion. The question though is it a million of the whole solution, or is it a million of only the solvent? And in both cases, it is per million or billion parts solution total. It is important that it's per total, but strictly speaking, it doesn't really make that much of a difference. And let me show you. If I have 10 ppm and I express it as a million total, or if I express it as 10 ppm and I express it as a million of the solution, you'll see that the difference between these two is basically neglectable, because those two quantities are very close to the same thing. And the bigger the parts per becomes, like a billion or even a trillion for that matter, the less of a difference it makes. but it is like mass percentage expressed as the total. Now, in the same way that we typically express solids as a mass percentage, ppm and ppb for solids and liquids would be in kilogram per million kilograms for liquids and solids, and for gases, it will be mole per million mole total. And you can see that for gases, this would be exactly the same if it would have been cubic meter per million cubic meters. So we can express it for gases as a mole per million mole or volume per million volume, and for solids as a kilogram per million kilogram. And the same for ppb. Now, the last concentration I want to talk about today is a special version of molarity, and we refer to this as normality. And this is specifically for acid and base reactions. Now, we express the normality as the gram equivalence per liter of solution. And this gram equivalent is the focus point of a lot of discussion. It is basically the valence of the acid or the base that is used in the neutralization of the other. So, in summary, from Wikipedia, the concentration types top per volume and bottom as a relative concentration, mass per mass, mass per mole, mole per mole, volume per volume, with all their symbols and how to calculate them. I hope this video helps you to understand concentration a little bit better.